WAEC 2024 OBJ question 1. We are asked to multiply 3.4 times 10 raised to the power minus 5 by 7.1 times 10 raised to the power 8 and leave our answer in standard form. So let's simplify now. We have 3.4 multiplying it by 10 raised to the power of minus 5, and we are multiplying it by 7.1, which is being multiplied by 10 raised to the power of 8. Now we can see here that this is a combination of standard form and which will also involve indices. So to do this, let's bring the terms of numbers together as well as the terms of 10 raised to the power. So let's begin with numbers. So we have 3.4 multiplied by 7.1, and then we'll multiply by the powers. That's 10 raised to the power minus 5 multiplied by 10 raised to the power of 8. So if we use our calculator for 3.4 times 7.1, we will have 24.14. And moving on, to simplify this 10 raised to the power minus 5 by 10 raised to the power 8, we go back in time and this we call on the laws of indices. The laws of indices states that x raised to the power a multiplied by x raised to the power b is equals to x raised to the power a plus b, and x raised to the power a divided by, it can be like this, let's use this, x raised to the power b is equals to x raised to the power a minus b, and x raised to the power a multiplied with the power b is equals to x raised to the power ab. So in this case now, let's just stop there. We have the multiplication sign here, which we call the addition law in indices. You can watch more lesson video on that on the YouTube platform. So we are going to apply this law. So with that, we are saying that a is equals to minus 5 and b is equals to 8. So applying that law now, we will have this to give us 10 raised to the power minus 5 plus 8, because we are adding the powers together. Moving on, so we have 24.14 multiplied by 10 raised to the power of 3, because minus 5 plus 8 is equals to 3. Now if you look at the options, we don't have any options of 24.14. All we have is 2.414. So all we just have to do now is to convert 24.14 to standard form, and to do that we have to move the decimal place one step backwards. And moving the decimal place to one step backwards to give us 2.414, we will have it to be multiplied by 10 raised to the power of 1, because we are moving to the left. Moving the decimal place to the left, when we move the decimal place to the left, we multiply it by 10 raised to the power of a positive value of how many times we move it, and if we move it to the right, that means we are multiplying by 10 raised to the power of the negative concept. Alright, so let's assume we want to move 2.414, we want to move 24.14 now, we want to move it to the right. Okay, so if we move it one step to the right, it will be 241.4 multiplied by 10 raised to the power minus 1. But if we move it backwards, okay, to the left, we will have 2.414 multiplied by 10 raised to the power positive 1. So this is what we have here, because we are applying moving to the left. So with respect to that now, we have 2.414 multiplied by 10 raised to the power 1, because everything here is equals to this, and we are multiplying by 10 raised to the power of 3. So let's release the brackets. So we have 2.414 multiplied by 10 raised to the power 1 multiplied by 10 raised to the power of 3. So in view of this now, what we have here will be an application of the law of indices. So let's apply the law of indices again. We know that this is a and this is b, and we will be adding the powers together. So adding the powers together, we will have this to give us 2.414 multiplied by 10 raised to the power 1 plus 3. So in view of that, plus 3. So in view of that, we'll have 2.414 multiplied by 10 raised to the power of 4. And this will give us option number C. We have WAEC 2024 OBJ question 2. Now we have a question here on sets, and we have that given that P, okay, P is a set such that the component of the set P ranges from the value of 1 less than P less than 20, where P is an integer, and R is equals to the set of 0 less than or equals to R less than or equals to 25, where R is a multiple of 4. Multiple of 4. So in view of that, now we are asked to find P intersection R. Okay, we understand that intersection means we pick what is common to P and R. Now if we have a question like P union R, that means we are combining. We are no longer selecting what is common. We are, let's say, combining the elements or components of P with R. Combining P with R. So now the first thing to do now is to write out the components of P and R. We understand that P is greater than 1 and less than 20, and the values of P are integers, and in this case R is greater than or equals to 0 and less than or equals to 25, where R is the multiple of 4. So let's begin with P. So P now gives us these components less than P less than 20. So we have the values of P, which is greater than 1, but it is less than 20. Now all the condition is that P is an integer. So therefore we are saying that P has the component of 2. 2 is greater than 1. So we write out 2 down to 20. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 down to 20. Oh no, we are down to 19 because it must be less than 20. So we have 12, we have 13, we have 14. Let's move to the next line. We have 15, 16, 17, 18, and 19. So these are the components of P. Now moving on, let's rewrite this. Moving on, let us now evaluate the component of R. We are given that R is equal to R, where R is greater than or equals to 0, less than or equals to 25, where R are multiples of 4. Multiples of 4. So in view of that, R is starting from 0 because R is greater than or equals to 0. So if R is starting from 0 and we are looking for the multiples of 4, so the first multiple of 4 here will be 4. That's 4 multiplied by 1. 4 multiplied by 2 will be 8. 4 multiplied by 3 is 12. 4 multiplied by 4, 16. Remember, we are going to less than or equals to 25. So it must not be greater than 25, but it can be equals to 25. So if 4 times 1 is 4, times 2, 18, 8, times 3, 12, times 4, 16, times 5, we'll have 20, and times multiplied by 6, we have 24. So these are the components of R. Now the question is, we should look for P intersection R. That means what is common to P and R. Now if we look at these two, now we are looking at P and we're also looking at R. We're looking for what is common to the two of them. So looking at them, let's use R to be the basis of our search. So we have 4 common to the 2, we have 8 common to the 2. Likewise, we have 12 common, 16 is common, but thereafter we don't have 20. Anything else is not common. So P intersection R simply will be equals to component of the common terms, that's 4, 8, 12, and 16. And this would give us option C. However, If we're asked to evaluate P union R, we know that we have to combine both P, all these elements here, bring them here. So this will be the first set. All the second elements here, we also bring them here, and then we remove the duplicates in them. WAEC 2024 objective question number 3. Now we are given the question to evaluate the number of terms in an arithmetic progression. The question goes thus: the first term of an arithmetic progression AP is 2 and the last term is 29. If the common difference is 3, we should evaluate the number of terms that are in the arithmetic progression. So before we proceed, let's write out the formulas involved in arithmetic progression. In AP, that's arithmetic progression, we also have geometric progression, which is called GP. For now, let's focus on AP, arithmetic progression. We have that the number of the nth term of AP, that's Tn, will be equals to the first term A plus n minus 1 multiplied by D, where D is the common difference. Similarly, the sum of the n terms is given by n over 2 into 2a plus n minus 1 multiplied by d. It can also be given as n over 2 into a plus l, where l is the last term. Now let's label the terms correctly. A is the first term. Okay, we have D to be the common difference. Similarly, N, we have N to be the number of terms. And likewise, we have L to be the last term. Now, in view of this now, we're given in the question that the first term of an arithmetic progression, A, is equals to 2. And the last term, L, is equals to 29. And the common difference is equals to 3. How many terms are we looking for? We are looking for n is equals to what? So with this, we have the first term, we have the common difference, we are looking for the number of terms, and we also have the last term. So how do we go about from here? If you look closely to this, we have that Sn is equals to that sum of nth term is equals to n over 2 into 2a plus n minus 1d. Similarly, we have this to be n over 2 to be equals to a plus l, where l is the last term. Now we can find an expression of last term. That means we have to make this term similar to this, so we have an expression of l. So let's split this further. Sn, sum of n terms, n over 2 multiplied by 2a. Now let's make it a plus n minus 1 d, and we understand that this is equivalent to n over 2 into a plus l. L is the last term. Now let's compare these two terms together, l and okay, let's begin with a. So let's look at a is equals to a. We've compared that. Similarly, this correspondent of a plus n minus 1d is equals to l. So with that, we're saying that the last term is a plus n minus 1 d. So now, if we look at the question that we have a, we have l, okay, we have a, we have l, we have d, and we are looking for n. So now we can use this expression now to evaluate the number of terms in the arithmetic progression. So with that, let's move a bit further and simplify the value of n. We are using l is equals to a plus n minus 1d. where L is the last term. So let's substitute our values. L is equals to 21, 29 in the question. We have A to be equals to 2. A is equals to 2. Similarly, we have N, what we are looking for, minus 1, and the common difference is equals to 3. So with this, we can subtract 2 from both ends. That means we will be left with 29 minus 2 on the left hand side, and on the right hand side we will be left with N minus 1 multiplied by 3. So this will result into 27 N minus 1 multiplied by 3. Let's divide both sides by 3 now. Dividing both sides by 3, the left hand side will be 9, and I'll be left with N minus 1. So simplifying further, we can have a value of N and say N will be equals to 9 plus 1, and N will be equals to 10. So the number of terms of the arithmetic progression is 10, and this is option C. Now we saw how we went. We looked at the two formulas of arithmetic progression, the nth term and also the number of the sum of n terms, the nth term and the sum of n terms. And we looked at what they gave us in the question, and for what they gave us in the question, we arrived at the formula that we can use to simplify for n. WAEC 2024 objective question number 4. We're asked to express in index form, and we are given a logarithm expression of log x to base a being added to log y to also to base a is equals to 3. Now, after this video, I want you to go back to the YouTube lesson where we dealt on conversion from index form to logarithm form, and here is the summary. So if you have the logarithm format of log a, let's say to base b, is equals to c, then therefore we are saying that in the index form that a will be equals to b raised to the power of c. Okay, so that means the base will become, we push this guy upward and we'll have b raised to the power of c. So in view of that, let's look at the laws of logarithm. The laws of logarithm goes thus: that if you have a, or say let's say log a plus log b, provided they have the same base, let's call the base c, then if they are adding together, then the result will be multiplication of the numbers. So that will give us log ab to the same base of c. Similarly, if they are being subtracted together, that's log a minus log b, and they have the same base c, this will be equals to log a over b of base c. So with this, we have the two basic laws of logarithm. And finally, if we have log of a, let's say to be c, where a is raised to the power of b, then this becomes a factor, or let's say a multiplier, and we'll have b log a to base c. This becomes backwards, and we have it here. Now let's apply it to the question that we have here. Remember, we are going to index form. So the first thing to do is to simplify the expression on the right hand side. That is log x to base a plus log y to base a, and we'll use the conversion index from logarithm form to index form to express the expression into index form. Okay, let's begin again. So we have log of x to base a plus log of y to base a to be equals to 3. Now, since it is addition, we have addition here. They have the same base a and a. So apply the addition law, and applying the addition law, we will have this to result into log of xy, because they are being multiplied at the end, multiplied by to base a rather. So we have log xy to base a, and this will be equals to 3. Now we want to apply the conversion base, okay, where we have, if you have log a to base b be equals to c, therefore the result will be equals to a is equals to b raised to the power of c. So in this case now, we will tag this as our a, okay, we'll call our base a here to be b, and this 3 to be equals to c. So let's not applying this formula now. Applying this formula, we will have it to give us a is equals to b raised to the power of c. So a is x raised to the power y, xy rather, to be equals to b, where our b is a raised to the power of c. So we have xy to be equals to a raised to the power of 3, and this is equivalent to option D. Now we have WAEC 2024 objective question 5, and we are asked to simplify 2p minus q squared, okay, minus p plus q also squared. So to simplify this now, we can choose to go in many ways. The first way is when we apply the principle of the sum square of a sum that says a plus b squared in algebra is equals to a squared plus 2ab plus b squared. Similarly, if we apply a minus b squared, we will have is to give us a squared minus 2ab plus b squared. Let's rewrite this ab. So we have a squared minus 2ab. Now, applying this principle might take a long time because we'll first simplify the sum here, okay, the square of the sum here, before we simplify the square of the difference here. However, since we want to be known for speed and accuracy, we will apply a different concept which is called the difference of two squares. So we have a squared minus b squared, and a squared minus b squared is simply a plus b multiplied by a minus b. A plus b multiplied by a minus b. So let's rewrite the question, and we will tag which is a and which is b. So we have 2p minus q, 2p minus q squared minus p plus q and squared. So with this, we have the negative in this case. We also have a, and likewise we have b. So we are saying that a is equals to 2p minus q and b is equals to p plus q. So if you apply this formula, that's a plus b multiplied by a minus b. So this will result into, okay, this will result into a is equals to 2p minus q. So we have 2p minus q being added to b, where b is p plus q. So we have p plus q, then it is being multiplied again by a minus b. So we understand that our a is 2p minus q and our b is p plus q. So yeah, we are applying the difference of two squares. Now with that, let's simplify further. Let's zoom in, and we will have 2p, let's open the brackets, minus q, 2p minus q, opening brackets is positive, we have p plus q. Similarly, let's open the brackets here with negative, so we have 2p minus q minus p minus q. So simplifying further, we will have that this negative p will nullify positive, negative q will nullify positive q, and similarly we would simplify this other side. So in view of that, this will result into 2p plus p and we'll have 2p minus p. Okay, 2p minus p, and this will give us p. And likewise we have minus q, which will give us minus 2q. So with that we'll have 3p multiplied by p minus 2q, and this is equivalent to option C. Now let's move on to WAEC 2024 objective question 6. Now we have a question here on sorts. After this video, I advise you to watch more lesson video on sorts on our YouTube platform. So let's move on. We have that if 3 minus 4 root 2 is being multiplied by 1 plus 3 root 2, then we should find the value of b in a plus b root 2. So let's take the formulas involved in sorts. That's the rule of sorts. The rule of sorts is quite simple. That's root a multiplied by b is equals to root a. Okay, root a multiplied by root b. Similarly, root a divided by b is equals to root a divided by root b. Okay, moving on. Now we have this question. We are asked to multiply 3 minus 4 root 2 by 1 minus 3 root 2. So all we just have to do in this case is to open the bracket. When we open the bracket, we will apply the rule of sorts. So let's go. 3 minus 4 root 2 being multiplied by 1 plus 3 root 2. So to simplify this, we multiply opening the bracket. So this will result into 3 into 1 plus 3 root 2, then minus 4 root 2 into 1 plus 3 root 2. Okay, 1 plus 3 root 2. So moving on, we'll open the bracket by 3. This will result into 3 plus 9. Okay, because 3 multiplied by 3 will give us 9 root 2. And we'll have minus 4 root 2 multiplied by 1. And we'll have minus 4 root 2. Root 2. And similarly, we'll have minus 4 root 2 multiplied by 3 root 2. So now we are now going to apply the rule of sorts in this case now. So we have to apply the rule of sorts here. So with that, this will result into 3 plus 9 root 2 minus 4 root 2. Since they are common terms, this will give us 3 plus 5 root 2, because 9 minus 4 is 5. And in the same vein, if we open this bracket now, this will simply give us 4 multiplied by root 2 multiplied by 3 multiplied by root 2. So this will give us 4 multiplied by 2, 4 multiplied by 3 multiplied by root 2 multiplied by root 2. So remember, here we are going to apply the rule of sorts. Here that says root a multiplied by root b is equals to root ab. We're going backwards. So therefore, this will give us 12 multiplied by this, applying the rule of sorts. Okay, we'll have root ab, and that is root 2 multiplied by 2. So that's 12 multiplied by root 4. 4 root 4 is 2. That's 12 multiplied by 2. Therefore, we'll have 24. So with that, we'll have 3 plus 5 root 2. This is 5 root 2. 9 root 2 minus 4 root 2 is 5 root 2. And this will give us minus 24, which will resolve there. So simplifying further, we'll have 3 minus 24 plus 5 root 2. Remember, we are putting it in the form of a plus b root 2. So simplifying further, this will give us minus 21 plus 5 root 2. Now, since we are putting it in the form of a plus b root 2, we can write it out and say this is a plus b root 2, and we are looking for the value of b according to the question. So if you compare the terms here, you can see that b is equals to 5 and a is equals to minus 21. So if b is equals to 5, this is equivalent to option A. So remember to go back to our lesson video on YouTube and learn the whole course on sorts to establish more understanding on sorts. WAEC 2024 objective question number 7. Now we have a question on simple interest. The question says find the time for which $1,250 will amount to $2,031.25 at 12.5% per annum simple interest. Now to proceed further, we are going to write out the formula of simple interest. We understand that simple interest is equals to the principal amount P multiplied by the rate R, okay, multiplied by the time T divided by 100. So we understand that simple interest is equals to PRT divided by 100. So from the question, the principal amount is given as $1,250 and the rate is given as 12.5% annum. We are looking for the time and the simple interest. Okay, we understand that the simple interest will be the amount, okay, minus the principal amount. So if you look at the question again, that's find the time for which 1,250 will amount to 2,031.25. So the simple interest is unknown, but we understand that the amount, the final amount, is $2,031.25. So therefore we're saying that the simple interest will be, that means the amount paid extra or the principal amount will be amount minus the principal. So this will be 2,031.25 minus 1,250, and simplifying this we'll have $781.25. Now we have the value for the simple interest, 781. So this is the simple interest now. So we have the simple interest to be 781.25, the principal amount to be 1,250, the rate is 12.5, and similarly we can now evaluate the time. So coming back here now, we can make T, so it's a formula, that's T for time. So T will be equals to simple interest multiplied by 100 divided by principal multiplied by the rates. So we will make our substitution. We have that the simple interest is 781.25. So we have 781.25 multiplied by 100, and similarly our principal amount is 1,250. That's $1,250, and the rate is 12.5%. So we'll just simply write it as 12.5. And now if we use our calculator for this, 781.25 multiplied by 100 divided by 1,250 multiplied by 12.5, we will have that the time is equals to 5 years. 5 years is equivalent to option D. So all we just did was to understand from the formula for simple interest to be PRT over 100, evaluated the simple interest, that's the amount paid, on the principal, that will be the final amount minus the principal, and we'll have the simple interest to be equals to 781.25, and then we made T subject to formula from the simple interest formula to give us simple interest times 100 divided by principal amount multiplied by rate. The rate is 12.5, the principal is 1,250, and we arrive at the time of 5 years, which is option D. Now we have an interesting question again on logarithm. The question says if log 2x minus 1 to base 3, that's log 2x minus 1 to base 3 is equals to 5. We should find the value of, okay, let us find the value of x. So we have log 2x minus 1 to base 3 is equals to 5. What is the value of x? So in view of that, let's recall on the law of logarithm, and which we also applied in question number 4, where we had to convert from logarithm form to index form. So the rules of log, we have that log a, okay, plus log b is equals to log ab, provided they have the same base. Let's say c, and c. Similarly, log a minus log b is equals to log a over b, provided they have the same base c and c. Also, we have the power law of log a raised to the power of b of log b to base c is equals to b log a to base c. Now, this is all the interesting parts in logarithm. But then if we have that log a converting from logarithm form to index form, that's log a to base b is equals to c. This is the log form. Now we are asked to convert it to index form. Then this will be equivalent to, okay, this will be equivalent to b a is equals to b raised to the power of c, and this we'll call the index form. Now we're going to apply all these principles in this question, but majorly the index form. So that's why we are making reference to question number 4. So simplifying further now, let's focus on the question. We want to look for the value of x, and to simplify this now is like solving indicial equation. So refer back to our YouTube video on indices and logarithm, where you learn about indicial equation. So all we just have to do now is to convert this to index form. So converting this to index form now, let's apply this. Therefore, we are saying that this is equivalent to a, 3 is equivalent to b, and 5 is equivalent to c. So we are saying that a, okay, is equals to b raised to the power of c. So a here is 2x minus 1 is equals to b, which is 3 raised to the power of c, which is 5. So we just converted from logarithm form to index form so that we can simplify the expression. Now if we have 2x minus 1 is equals to 3 raised to the power of 5, the question now is what is 3 raised to the power of 5? So we have 2x minus 1 to be equals to 243. So with this we can find the value of x. So with that done, so x will be equals to 243 plus 1, because we're moving 1 from the left hand side to the right hand side. And we have 2x to be equals to 244. If we divide both sides by 2, we have that x is equals to 122. And this is equivalent to option D. So all we just did, convert from logarithm form to index form, and from index form we found the value of x to be equals to 122. And now let's proceed to question number 9, WAEC 2024 objective question number 9. The question says the population of a town increases by 3% every year, and in the year 2020 the population was 3,000. Find the population in the year 2003. So we are saying that at year 2000 the population is equals to 3,000. Okay, the population is equals to 3,000, and we are looking for the population at the year 2003, where we understand that the population increases by 3% every year. So every year there's a 3% increase by the value of the previous year. So now if you want to evaluate the population of 2001, okay, because to evaluate the population of 2003 we have to know the population of 2002. To know the population of 2002, we have to know the population of 2001. So we can evaluate the population of 2001 because we know the population of year 2000. So the population of year 2001 is equal to the population of 2000 plus the 3% increase of the year 2000. Okay, so with this, we can say that the population of the year 2001 is equal to 3000 plus 3% increase, that's 3 over 100 of 3000. So with this, we can use our calculator and we'll have this to give us 3000 plus 90. And we have the year of the population of 2001 to be equals to 3090. Similarly, let us now evaluate the population of the year 2002. Okay, this 2001, let's move to 2002. The population of the year 2002 will be a 3% increase on the previous year, as a 3% increase on the year 2001, plus 3% of 2001. So with this, we understand that the population of 2001 is 3090. So having a 3% increase of 3090, this will result into 3090 plus 92.7. So simplifying further, this will give us 3182.7. And this is the population of the year 2002. And finally, let's solve the question which says we should find the population in the year 2003. Now, the population in the year 2003, that's P 2003, will be the 3% increase on the year 2002 plus 3% increase of the year 2002. So this will give us 3182.7 plus a 3% increase of 3182.7. So this will give us 3182.7 plus 95.451. And simplifying further, this will give us 3278.181. Now, since the population cannot be decimal in nature, this is the final expression of P 2003. So we simplify to the nearest integer, this will be 3278. So we have 3278 will give the population of 2003, which is equivalent to option B. So for more understanding, let's take a quick recap. We're given the population of the year 2000 to be equal to 3000, and we are asked to evaluate the population of 2003, given that there is a 3% increase every year. So with that, we have to evaluate the population of 2001 by the 3% increase of year 2000. Then we evaluated the population of 2002 by the 3% increase of 2001. And finally, the population of 2003 by the 3% increase on the year 2002. And then we arrived at the answer of 3278, which is equivalent to option B. So we have WAEC 2024 objective question number 10. We are asked to find the percentage error, and the question says a trader gave a change of 540 naira instead of 570 naira to a consumer. Find the percentage error. Now, the given is equals to 540 naira, and the actual change was meant to be 570 naira. So with this, we can see that there is an error. So the error will be the actual minus the given, the actual change minus the given change, and the actual change is equals to 570. Okay, 570. The given change was 540, and this will be equals to 30. So we have, let's insert our units. 540 naira It's 570 naira, and we have 30 naira. Now, in the principle of error, evaluating error, or let's say percentage error, we understand that percentage error will be equals to the error itself divided by the original or the actual. Okay, sometimes we use original multiplied by 100%. So now we can apply this principle here now and say that this error now is equals to 30, the actual is equals to 570, okay, multiplied by 100. So simplifying further, 30 divided by 570. Now, before we proceed to simplify, we can see that our options are in fraction. So we must ensure that we have the answer in fraction. So simplifying further, for 300 divided by 570, we'll have 1 divided by 19 multiplied by 100%. Okay, so with that, we will have, this is as percentage embedded in it. So we have 100 divided by 19 percentage. 100 divided by 19%. So in view of that, let's divide by 19. So dividing by 19, we'll have 5 whole number, and we are left with 5 over 19%. And this is equivalent to option A. So all we just have to do, let's take a quick recap. We're given the change of 540 naira, and the actual change is meant to be 570 naira. So we evaluated the error to be actual minus the given. That's the original change minus the given change to give us 30 naira. So we applied the formula of percentage error to be error divided by actual or original multiplied by 100%. And since our options are in fraction, then we will have the answer to be 5 over 19%, which is equivalent to option A.